Okay, we're on lesson 7.3. We're going to look at number 37 on page 392. And we're going to look at parts B and C. We're going to start with part B. Find the volume of the solid generated by revolving the region bounded by the parabola y equal x squared and the line y equal 1. This is 37. Y equal x squared is a parabola, something like this. Y equal 1. Go like this. So here's our region in here. Y equal 1, y equal x squared. Okay, that's our we always want to do a two-dimensional drawing first. Now, for 37b, they say revolve that region about the line y equal 2. Revolve about y equal 2. So y equal 2 is up here above y equal 1. So let me draw a picture of this. Here's our parabola again. Here's y equal 1 right there. Here's y equal 2 up here. So this is my axis of revolution or axis of rotation right here. Here's my region. I'm going to be revolving it, so I'm going to use some type of circular formula. So either the disk method or the washer method. Now I see this white space here. When you see white space between the region and the axis of rotation, that means you should use which one, the disk or the washer method?
Washer.
Washer method. Because what that means is when you revolve it, so all I'm going to do to draw is I'm going to reflect this parabola over this line, reflect y equal 1 over that line. So I'm going to get this. And to draw it, I'll kind of like if you took an apple, a round apple, and took the core out of the middle, and you had this hole through the middle of your apple, that's kind of what it would look like. All right? Something like, this is not exactly right, but it looks something like this green shape, okay? There's going to be in the hole in the middle, okay? So when you have a hole in the middle and you start slicing it, you end up with, the slices will be washers with holes in the middle. So we're going to have to use the washer method here. If I was going to try to draw this washer, which I'm going to try to do, and you're going to slice it into washer shapes. So if I'm going to draw it, it looks something like this. Here's my washer surface area right there. Here's the thickness of the washer. That thickness, or the skinny dimension right there, runs sideways. So if it runs sideways, is that a change in x or a change in y? Change in x, so it's dx. That tells me everything needs to be in terms of x. The integrand has to be in terms of x, the bounds have to be in terms of x. So my volume, let's do it right here. This is for part B. Here's my formula, pi times the big radius squared minus the little radius squared times dx. Going from A to B. Now the large radius is always going to run from your axis of rotation, which is y equal 2, to the closest curve, right there. So what is that distance from y equal 2 to y equal 1? 1. So the small radius will be 1. The big radius is going to run from the axis of rotation all the way to the furthest curve. So if the axis of rotation is at 2 and the furthest curve is x squared, what would my big radius equal here? 2 minus x squared, right? Do top curve minus bottom curve. Here we did 2 minus 1 to get 1. Here we're going to do 2 minus x squared. So a big radius on this problem is 2 minus x squared. So now I'm just going to plug that in right there. 2 minus x squared minus little radius we said was 1. 1 squared would just be 1 times dx. Now, I need to figure out my bounds. My bounds are going to be x's because everything's in terms of x. So I'm going to have to look at this x coordinate and this x coordinate, which are going to be negative 1 and 1. Now, how did I know those are going to be negative 1 and 1?
That's where the parabola and y equal 1 cross.
Yeah, that's where they cross. If you put 1 in for x, y would equal 1 squared, which is 1. This is the point 1, 1 right here. If we cross at y equal 1. Okay, or another way you can do is you could set these two equal. You could set x squared equal to 1. And then take the square root on both sides. X is going to be equal to plus or minus 1. So, or you could just graph it out. If you graphed out the parabola by hand, you'd figure out that they cross at 1 and negative 1. Now, if I was going to do this by hand, I might do something different, because I can find the volume running from negative 1 to 1, and that'll give me the correct answer. But what if I decided, I don't want to do that. I don't want to go from negative 1 to 1. I'd rather go from just 0 to 1 and just look at the right half. Then what would I have to do to my answer? Multiply by 2. So if you wanted to, you could find the integral from 0 to 1 and then just double your answer, because that would only give 0 to 1 would only give you half of your volume. Okay? What would be the advantage of doing that? If you're doing it by hand?
Less words.
Be easier, why? No negative numbers. You don't have to deal with negative numbers. So if you don't like dealing with negative numbers, that's something you could do. Okay? But for our purposes here, we're going to type it on the calculator. I'm going to want you to show this on your paper. Also show the answer. Now, you don't have to show this next step, but it's going to be helpful. If you have problems with the parentheses and where to put them when you type them in, this might be helpful to you. To write it out like you're going to put it on the calculator. So you're going to do numerical integral, which is math 9, and then you're going to have a parenthesis, then you're going to have another parenthesis, 2 minus x squared minus 1. Then you're going to have to do comma x, comma negative 1, comma 1. Let's do that and get the answer quick. Alright, so you're going to hit math 9, and then parenthesis, 2 minus x squared minus 1, comma x, comma negative 1, comma 1. 3.73 repeated.
Is that pi too, right?
And then don't forget the pi out front. And the label will be cubic units, because we're doing volume. If you wanted to, you could just take 3.7, you could take that answer times pi also, and that would be the other possible answer. If you hit times pi, 11.729 cubic units would be another correct answer. Any questions about that now? Okay, let's move on to part C. Still doing number 37. Still on page 392. Part C, revolve it about the line y equal negative 1. So you still get this, you still have the same region, so I'm going to redraw that real quick. Still have y equal x squared and y equal 1. But now you're going to revolve around y equal negative 1. This is y equal 1. This is y equal x squared. This is the x-axis. There's my region. So I look at my region, I look at my x rotation, I see white space again. So what method am I going to use again? Washer method. Yeah. So let's try to revolve it and draw the picture. Whoops, that's not drawn right. Try this again. And around y equal negative 1. So if this is at 0, 0, where's the reflection of 0, 0 going to go if you're reflecting over y equal negative 1? 0 and what?
Negative
0, negative 2, yeah. Because that point's going to reflect over and land down here at negative 2. And your parabola is going to be concave down instead of concave up. You're going to have something like this. Try to draw it like this. So you're going to have a cylinder with kind of an hourglass hollowed out of the inside. That's how I would describe it. It's a cylinder, but on the inside it's hollowed out. And if I was to draw a disc, it would look something like this. small radius, always runs from the axis of rotation to the closest curve. So that would be your small radius right there. So what would be the equation of the small radius? What would be the expression for the small radius?
-1 minus x squared.
Top curve minus bottom curve.
Oh, x squared plus 1.
X squared, that's your top curve right there, minus -1. So x squared minus -1, which would be the same as x squared plus 1. So top minus bottom. Okay? Next, your big radius is going to run from the axis of rotation to the furthest curve. So our big radius, let's write that down here. So it'd be what minus what?
1 minus 1.
Be 1, my top curve, minus -1 here. So 1 minus -1 would be 2. So no matter where I slice it, the radius is going to be 2 of the big circle. So I just figured out expressions for this right here was my little radius. That came out to x squared plus 1. And then all the way from here, all the way up to here, that's your big radius. All right, let's go ahead and plug it into the washer method now. So volume equals pi times the integral. What my bounds? Are my bounds still going to be the same?
Yeah.
Yep, still going to be -1 to 1. Still x values. Big radius squared, so that's going to be 2 squared, which would just be 4, minus your small radius squared, so that's x squared plus 1 squared. And then don't forget your dx. dx is the thickness. Let me draw this in here a little bit. Dx represents a very small, I call it thickness, but it's actually very thin. This little thickness of your disk runs sideways, so that's a dx. If you don't put that dx in there, you're not really doing volume. Okay? This integrand represents the surface area of the washer. The dx represents the thickness. When you take the surface area times the thickness, you get the volume. The integral adds up the volume for you. Anybody know what you get if you type that in the calculator?
4.267.
4.2 what? 4.267 pi cubic units. Anyone else type it in and get the same thing?
Yeah.
Okay.